so example 5, it says a sector of a circle is the region bounded by two radii. First off, radii is the plural of radius. So here radii, that just means more than one radius. And the intercepted arc. What is the area of sector MQN? So we got some of the same terminology we've used in the previous section of this where we did arc length. Before, last section, we were finding the length from M to N. Now it wants to know the area of the shaded portion, how much space is being occupied by that blue shaded region. Just like arc length was related to circumference, the sector area, the portion of the area of the circle, which is not the whole area, but the portion of the area, revolves around the area formula of a circle. So we know from 6th, 7th, 8th grade, whatever year you learned it and probably revisited in other classes, the area formula for a full circle is pi r squared. And I know you guys know that because when I said what's the circumference formula, somebody said pi r squared. So at least it's somewhere in your brain, right? So we've seen this before. And again, that's for a full circle. If you write the formula on your paper, make sure you leave that little space that I did. I did it on purpose. Leave a little gap in between the equal sign and the pi r squared. Okay. Just like arc length, we took the circumference formula, which was 2 pi r, and multiplied it by the portion of the circle we're dealing with. Specifically, we want to know a radius and an angle. That's an R, that's an A. If you can't see, I didn't have a lot of room to put that in there. We happen to know the radius and angle in this picture, but for the sake of a formula, pi r squared for any circle radius r, and the angle measure we're dealing with is A divided by 360. Okay, that's assuming the angle's in degrees. A is in degrees. We also, on Monday, dealt with the idea of radians instead of degrees. We found out there's pi radians and 180 degrees. So if we double that, 2 pi radians and 360 degrees. So 360 degrees and 2 pi radians mean the same thing. So if I'm looking for a formula if A happens to be in radians, the area is going to be, again, pi r squared multiplied by A over 2 pi. So A in degrees divided by 360 degrees, A in radians divided by 2 pi radians, in both cases multiplied by pi r squared. The radian formula, just like in the arc length radian formula, we do have some cancellation possibilities if you want to. This one doesn't simplify quite as nicely as the arc length one does, so sometimes people don't do this. But if you reduce the pi's out, you're going to get AR squared over 2. That is legal. So you square the radius, multiply by the radian measure, divide by 2. Again, if it's given in radians. For me personally, that's like memorizing a new formula when the old formula was what I already know times a fraction. So I usually go with this one myself, but you're welcome to use the simplified version of that one. In this case, the angle of the central angle here, MQN, is 140 degrees, not radians, so we'll be using the degrees formula. So basically your technique here is we're trying to find the area of a sector, identify the angle type to identify the correct formula, write the formula down, and there's so many formulas, if you write them down again and again and again, you will eventually have them stuck in your brain. All right, and that's a good place for them to be stuck. Okay. The measure of A is 140, the measure of R is 8, so I'm going to simply substitute those numbers in. So A equals 140 over 360 times pi r squared. Now for me personally, you can write 8 squared if you want to. All right? But then all of a sudden you got an order of operations scenario. You got a power happening and you also have multiplication division happening. The power has to happen first. for me, if it's a simple squaring of a number, 8 squared equals 64, I personally would just write 64 in. Just mentally square that. If the radius was 17.03 or something weird like that, I'm probably going to write 17.03 squared. But if it's some number, 7 squared is 49, 9 squared is 81, 10 squared is 100. If it's some number that's easy to square, I'm just going to mentally square it, just put that in the formula. Because again, by the order of operations, that's the first thing that should happen anyway. So as you write your answer down in your formula structure, if you just go ahead and square that number in your head, it makes life easier. And then it's just the same structure it was when we did arc length. We got a bunch of numbers being multiplied, divided by 360. So on my calculator, I'm going to type in exactly 140 times 3.14 in place of pi times 64 divided by 360. Just do the divided by last. Good time to do it. And it doesn't specify. I'm going to round to the nearest tenth. That's what they've been doing mostly. So 140 times 3.14 times 64 divided by 360 comes out to 78.2, 78.15, 1111. So 78.2 if we round to one decimal place. Now, the unit on the radius is centimeters. So when I did 8 centimeters and I squared it, I actually have centimeters squared in the formula. So the unit of length, or the unit of area, should be centimeters squared. So find the area of a sector. Okay. Again, really get yourself familiar with this terminology. Length of a sector is the arc length formula. Length of an arc length formula. Area of a sector, use the area of a sector formula. So make sure that you have the length of arc, area of sector. The edge of the circle is the arc. The piece of pie being cut out is the sector. So make sure you have that under control as far as what they're asking you to do.